So now we're in section 3.5, rational functions and their graph. This section consists of three parts, with the first part being finding the domain. If you recall, the domain of a rational function is the set of all real numbers except the x values that make the denominator 0. So the key thing to remember here is the x values that make the denominator 0, not the numerator, but the denominator. So if we have a problem like f of x, f of x, let me, my style is here, okay. F of x is equal to x minus 25 all over x minus 5. So in my definition of how to find a domain, when I mentioned that it has to be a set of all real numbers except the x values that make the denominator equal to 0. So we're only looking at the denominator here. So looking at this, we would set the denominator equal to 0. So we say x minus 5 equals 0. And we know that when x is equal to 5, because we solve for x, it makes the denominator 0. So our answer for this particular problem is from negative infinity to 5, and then the union of 5 to infinity. Okay, so let's try another problem here. Once again, we're still finding the domain of the rational function. So if I have g of x is equal to x all over x squared minus 25. Well, once I look at this problem, one thing I know about the denominator here, with the denominator being this bottom part here, one thing I know about that is it meets the rules for the difference of squares. And if you recall, the difference if you recall, the difference of squares was a minus b and a plus b. Sorry, put x here. A minus b and a plus b. A plus b. So we can easily see that this is x plus 5 and x minus 5. So we factored our denominator as x plus 5, x minus 5. Because whenever we can factor, we have to do it. So now we see it's x plus 5, x minus 5. So we know that whenever x is a negative 5 or a positive 5, that would set our denominator equal to 0, which will make it undefined. So our x here is equal to negative 5 or a positive 5. And the way that we will write that in solution set is, we will say from negative infinity to negative 5, the union of negative 5 to 5, and then the union of 5 to infinity. And that's our final answer for this problem here. So whenever x is negative 5, because it's negative 5 plus 5, that's 0. We'll have negative 5 minus a minus 5, that's 10. But 0 multiplied by anything is 0, so that would make the denominator equal to 0. Okay? All right. So let's do one more. H of x is equal to x plus 5 all over x squared plus 25. Now, looking at this problem, we cannot apply the difference of squares here because this is x squared plus 25. As opposed to the last problem that we had, it was x squared minus 25. So that's why we could apply the difference of squares. So for this problem here, what number can we plug into the denominator that will make the denominator equal to 0? Well, if we plug 0 in here, it's just going to be 25. So, that's not going to work. If we say 5, well, that'll be 25 plus 25. If we say negative 5, well, that'll be 25 plus 25. So let's just see, just for demonstration purposes here. So if we say a negative 5 squared plus 25, that will be equal to 25 plus 25, because we know that a negative and a negative gives us a positive. So that's what this is, a positive 25. If we say 5 squared plus 25. Once again, it's positive, so it's still 25 plus 25. So we can, let's say x squared plus 25 is equal to 0. Let's say x squared is equal to negative 25. Get the square root of both sides. You see where I'm going here? Is that then we can say x is equal to I square root of 25, which is equal to 5i. Sorry about that. Let me erase this. 5i. But have some good news here. We don't really have to do this right here. Because if we place if x is equal to 5i, and we put 5i in here, 5i squared plus 25, still, it's not setting the denominator equal to 0. So, the answer to this problem is no real numbers cause the denominator equal to 0, so the domain consists of all real numbers. And the way we write that is negative infinity to positive infinity as our final answer. The domain consists of all real numbers. Okay, so that's the last problem I'm working when it comes to finding the domain. Now, we're going to talk about locating vertical asymptotes. If f of x is equal to p of x over q of x is a rational function in which p of x and q of x have no common factors and a is a 0 of q of x, the denominator, then x equals a, is a vertical asymptote of the graph of f. So, that probably may not make no sense whatsoever to you. So let's write it out as a problem. Well, use a problem as an example. F of x is equal to x over x plus 11. So this function do not need to be simplified because the numerator and the denominator do not have common factors, but we can factor things out and cancel some things out. So we find the zeros of q of x, in which the definition told us that q of x is the denominator. So we find the definition, find the zeros of that. So we say x plus 11 equals 0. Therefore, we know x is equal to negative 11. So the line x equals negative 11 is the only vertical asymptote of the graph f of x is equal to x over x plus 11. So this is our final answer right here. X is equal to negative 11. Hope you're able to capture that because it's so simple that sometimes people tend to look at problems like this and be like, there has to be something else. But in essence, there isn't anything else left here. This is the answer. X is equal to negative 11. So let's do another one here, the vertical asymptote. Let's say g of x is equal to x plus 3 over x squared minus 9. I hope you notice here that the denominator here, x squared minus 9, we can apply the difference of squares there, so we can factor here. Once we do that, then what we have is x plus 3 all over x plus 3, x minus 3. Now that we've done that, we can cancel some things out. X plus 3 cancels out, right? Of course it does. Now, our g of x is equal to 1 over x minus 3. So now we have to find the zeros of the denominator, and we do that by saying x minus 3 equals 0. So we say x minus 3 equals 0. Solving for x, we know x will be equal to 3. So the only zero of the denominator in simplified form is 3. So the line x equals 3 is the only vertical asymptote of the graph g of x is equal to x plus 3, x squared minus 9. Okay. So let's move on. Now, locating the horizontal asymptotes here. So when we talk about the horizontal asymptotes, a tad bit different than the vertical asymptotes because like I said, vertical is vertical, this is horizontal. But the approach here is that once we have this horizontal asymptote, where once we're given a function, we have this f of x here. As you can see, this long drawn out formula here. Okay, pay attention to this because it says a of n x raised to the n all over b of m x raised to the m plus, then it just goes on and on and on and on. But the key things to note here would be these three things here, and what to do if the n is less than the m, the n is equal to m, or the n is greater than the m. So once again, this probably doesn't resonate well with you just being in this form here. So let's put a problem out here and start working it. So if we have f of x is equal to 18x all over 4x squared plus 5. First thing we want to do here is find our n and our m, because right up here it talks about the n and the m. So what is our n here and what is my m? Well, my n is 1 because x is raised to the 1 power. My m here is 2. So I know that my degree of my numerator is less than my degree of my denominator. So n here is less than m. And then we see where it says when n is less than m. Oops, not right there. My mistake. Okay, so when n is less than m, that's this one right here. The x-axis or y equals 0. So it says the asymptote, the horizontal asymptote is y equals 0. And that's our answer. Y equals 0. So it's real easy. Just find your n and your m, and you come up here to 1, 2, or 3. You're trying to figure out which one is it n. Is it less than m, equal to m, or greater than m? So let's do another one here. So another problem I have is f of x is equal to 12x squared all over 4x squared plus 3. What is my n? What is my m? So my n here is 2. My m here is 2. So what does it say when n is equal to m? Here it is. If n is equal to m, the line y equals a over b is the horizontal asymptote of the graph of f. So, like I said, we have our n is equal to m here. So we know that y is equal to a to the n over b to the m. What is our a here? 12. What is our b? 4. Simplify that, 3. So the equation of the horizontal asymptote is y is equal to 3. That's our answer. Y is equal to 3. All right. And then, if n was greater than m, the graph would just have no horizontal asymptote. Okay, so now the strategy for graphing a rational function. As you can see, there are a lot of steps here in order to graph a rational function. So I cannot copy this one to the next page, this particular screen here, because there's so much written on this one right here. So instead, what I'm going to do is I will just pick a problem and show how to go about working these steps right here, each one of these. So the steps are provided to you. They're in your book, and I'm showing them here as well. But it's very straightforward. All you have to do is follow the steps. So let's see. First problem would be f of x is equal to 2x squared all over x squared minus 9. And the first step here is you're trying to determine whether the graph of f has symmetry. If f of negative x is equal to f of x, then it has y-axis symmetry. Y-axis symmetry. S-Y-M-M. It's abbreviated right there. If f of negative x is equal to negative f of x, that goes with that, then we have origin symmetry. All right? So, let's try this. F of negative x is equal to 2 negative x squared all over negative x squared minus 9. So what I've done is, everywhere there's an x up in here, everywhere there's an x, I plugged in a negative x for that. So once I do that, then I know my f of x is equal to 2x squared over x squared minus 9. So I can say that the graph is symmetric with respect to the y-axis. Why? Because my f of negative x is equal to my f of x. So that's why I can say that. If you're still a little confused, you're going, okay, well, how did you get this 2x squared over x squared minus 9? Well, a negative x squared, a negative x, and a negative x is a positive x. So that's how I got this 2x squared. And then negative x squared is negative x times negative x. That's x. So it's x squared minus 9. So both of those are equal. So like I said, it is symmetric with respect to the y-axis. Symmetric with respect to the y-axis. Now, step number 2 says find the y-intercept. Find the y-intercept. Well, we found the y-intercept in a previous lecture, but it tells us find the y-intercept by evaluating f is equal to 0. So, f of equal to 0, and we know that our problem is, I'll write the problem up here again for reference, 2 x squared all over x squared minus 9. So it's 2 times 0 all over 0 squared minus 9. And we know what that is. That's 0. Because 0 over negative 9 is equal to 0. So it's passing through the origin 0, 0, right? All right. Now, this was step number 2. Step number 3 is find the x-intercept by solving the equation p of x equals 0. Find the x-intercept by solving the equation p of x equals 0. So we know that, once again, it's 2x squared all over x squared minus 9. And we know that from previous problems that it's written as p of x over q of x, right? So this is p of x is up top, q of x is down the bottom. But for finding the x-intercept, it says find the x-intercept by solving the equation p of x equals 0. By solving the equation, p of x equals 0. So p of x is 2x squared in this problem here. So 2x squared equals 0. What's that? Exactly. So our x here equals 0. Because if we take this 2, divide by 2 on both sides, right? you still don't understand how I got that, let's do this. Divide by 2 on both sides. This cancel out. X squared equals 0. Square root of both sides. Square root of 0 is 0. So x is equal to 0. So we know it's passing through 0, 0 here as well. So let's move on to the fourth step. So the fourth step is find any vertical asymptotes by solving the equation q of x equals 0. Find vertical asymptotes. Find vertical asymptotes. And once again, the problem is 2x squared over x squared minus 9 over x squared minus 9. We know we have a p of x and a q of x. So this is my p of x. This is my q of x. So we have that. Make this a bit nicer down here. Q of x. All right. Make my line. So find the vertical asymptotes by solving the equation q of x equals 0. So I take my x squared minus 9 and set it equal to 0. X squared minus 9 equals 0. X squared is equal to 9. Get my square root of both sides. X is equal to plus or minus 3. So that's my vertical asymptote, plus or minus 3. Now my horizontal asymptote, 5. Finding my horizontal asymptote. Again, the problem is 2x squared over x squared minus 9. Horizontal asymptotes, we know about the n equals m. N is greater than m, n less than m. You can recall that from the previous section. Well, part when we went over the horizontal asymptotes, we did with n greater than m, n equals to m, n less than m. An example I gave was n is equal to m. Well, for this problem here, we know our n is equal to 2, and our m is equal to 2. And if you recall, when n is equal to n is equal to m, then we have to use the y is equal to a to the n, b to the m. So for this problem, our y is equal to 2 over 1, so it's just 2. Now, if we have step number 6, which talks about plot at least one point between and beyond each x-intercept and vertical asymptote. So, what we do here is that we know our x-intercept here. I'm trying to write this out. Plot at least one point, between, use my shorthand here, between and beyond each x-intercept and vertical asymptote. And vertical asymptote. So really, it's saying find points that you can use any point except the x-intercept and the vertical asymptote. So we know our x-intercept is 0, and our vertical asymptote is -3 and +3. So I'm just going to draw a table like this. I'm going to put my x there, and I'm going to put my f of x here. I'm just going to draw some lines. I know that my equation or formula would be, let's see, my x-intercept, I said that was, based on the problem that we previously did, x-intercept was 0. My vertical asymptotes were -3 and 3. So it has to be numbers between and beyond this right here. So beyond that would be -4 would fit that bill. -2 would be between. 1 would be between. Beyond would be well, 2 would be between, and then beyond would be another 4. So if I plug these numbers, each of these numbers into our f of x, which our f of x is, it didn't change, 2x squared over x squared minus 9. If I plug negative 4 in for x squared in this problem here, it will come back to like a 4.6. If I plug negative 2 into there, it'll come back to be a negative 1, and then negative 0.5 here, negative 1, and 4.6. So, now that I have my points, as well as my other information that I have from steps 1 through 5, now I can go and I can plot this as a graph here. So, my last step would be step number 7 is to plot. Plot my graph. I'm going to draw my graph here the best that I can. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so now I have my graph here, and I have to plot my points. So I want to go ahead and say, where is my horizontal asymptote and where is my vertical asymptote? So once I have that information, I just want to go ahead and put that on my graph first. So I know that my vertical asymptote is positive 3 and negative 3. So I'm going to come over here. I said that my vertical asymptote is positive 3 and negative 3. So I know my negative 3 is right here. I'm just going to draw a line like this. Positive 3 is right here. And my horizontal asymptote is 2. So I'm just come over here, it says 2. So I'm drawing this line right here. Alright. So now that I have that, I'm going to come over here and I'm going to erase this right here because I'm going to need this space when I start drawing. I'm going to make it a little smaller. 7. Plot P L O. Well, it's not coming out, so I'm just going to use number 7 there. Step number 7. Just remember that. So I have some more space to draw my lines here. So dotted line, alright. Well, not a dotted line, but a dashed line. Okay. So now that I have my asymptotes out here, my vertical, so it's my horizontal, now I'm going back to my graph because I had some points with my coordinates that I listed from step 6. So it's negative 4 and 4.6. So negative 4, 1, 2, 3, 4.6, 4.6 is somewhere up in there. Now I have a negative 2, negative 1. Negative 2, negative 1 is somewhere right there. Then I have a 1 and a negative 0.5. 1 or negative 0.5 is somewhere up in there. I have a 2 and a negative 1. 2, negative 1, that's somewhere right there. Then I have a 4 and another 4.6. Somewhere right there. Then I have my origin. It's passing through. 0, 0 is right there. Okay, so now I have to graph this. Well, the intent of my horizontal and vertical asymptote is saying that I cannot go outside of those boundaries. So for this line right here, it's going to come down through that point and then curve like that. Same here, because it's going to come down through that point and curve like that. And from this one, I'm not going to leak it out of those boundaries. With this, if my graph was correct, being that all these lines would be equally spaced apart and everything, I would have went through this point here. I'm going to make it look a 0.1/2 is probably right there, so that would fix my line. So it's going to come down like this and down like that, and that will be my graph for this problem here. So I'm only going to do one of these problems because I want you to go and you practice plotting rational functions, graphing rational functions. It's 7 steps. And each step, it gives you a very, very clear indication of what to do for each steps in the book. The steps that I gave you, as well as what we just went over as far as the domain, the vertical and the horizontal asymptotes, in which you will only need the vertical and the horizontal asymptotes when graphing. It tells you what to do to find a y-intercept, as well as what to do to find an x-intercept and determine symmetry. From there on, you're just finding your points and just plotting them on the graph. So that actually concludes section 3.5, and we'll talk about it some more if you have questions during class. Okay, thank you.